Good day, I am Roniel Garcia and today I'm with my group mates, Lady Antabiolo, CJ Maglalang, Matthew Dulnuan, Kim Pauline Tinawin, and Josabel Kapingian. So today our topic is about the hydrogen power plant. So let's proceed. So first, what is a hydrogen power plant? A hydrogen power plant is a concept designed for a new widespread of electricity. Essentially, it is a facility which uses hydrogen to produce electrical energy. So, sabi dito, hydrogen uses hydrogen. So, ibig sabihin, pure hydrogen and it doesn't form any compound with other elements. So, next, let's move on sa working principle ng hydrogen power plant. So, large tanks of liquid hydrogen will feed into thousands of hydrogen fuel cells. These fuel cells are solid structures containing an electrolyte fluid and two terminals, much like batteries. So, itong hydrogen fuel cells ay the main part of hydrogen power plant. So, sabi dito, yung hydrogen fuel cells daw ay much like batteries. So, sa madaling salita, kung gusto mong malaman yung working principle ng isang hydrogen power plant, kailangan himay-himayin mo muna yung information kung paano nga bang gumagana yung isang battery. Kapag ka naaral na yon kung paano nga bang gumagana ang isang battery, magli-lead to sa working principle ng hydrogen fuel cells since it is much like batteries nga daw. So, malalaman mo na yung buong concept na to, kung paano gumagana to, yung working principle ng hydrogen power plant. So, the reactant flows into the cells, in this case, hydrogen and oxygen. Yung reactant daw, nag-flow, papasok. Okay, mamaya papakita natin yan. They intermingle with the electrolyte to produce an electrical charge and water as a byproduct. The water flows out into another port while the electricity is siphoned off the terminals and held in gigantic multi-ton batteries. The electricity resides in the batteries until it is needed, in which case it is sent out through the local power grid just like any other type of power plant. So ito papakita natin kung paano nga yan. So ito sinasabi, the reactant flows into the cell. Yan, oxygen at hydrogen. They intermingle with the electrolyte. Yan. Kagaya nga sa battery, yung anode and cathode nga ay nakababad sa electrolyte. Yan. Parang ito, they intermingle with the electrolyte. At yung water as a byproduct. Yan. So next, let's move on sa battery parts and functions. Electrolyte, anode, and cathode. So, first electrolyte, it is a chemical compound that conducts electricity by changing into ions when melted or dissolved into a solution. It can be liquid or a paste-like substance. Example, ammonium chloride, zinc chloride, potassium hydroxide, lithium, tin, phosphorus sulfide, and sulfuric acid. Next is anode. It is the negative or reducing electrode that releases electrons to the external circuit and oxidizes during the electrochemical reaction. Example, zinc, metallic lithium, and lead. Cathode. It is the positive or oxidizing electrode that acquires electrons from the external circuit and is reduced during the electrochemical reaction. Example, manganese dioxide, carbon, lead dioxide, and copper. So take note, anode is the negative and cathode is the positive. So next, papakita naman natin kung paano nga bang interconnected ng tatlo, kung paano silang nagka-connect-connecta at kung paano ginagawa nila.
So let's proceed to the schematic diagram ng battery. We can see how the three vital parts interlinks one another. The anode and cathode are being submerged within electrolyte solution. Kung makikita nyo sa picture, ang anode at cathode ay nakalubog sa electrolyte solution. Sa pagitan nilang dalawa, ay matatagpuan naman ang semi-permeable barrier. This simply prevents the excess of electron within the anode side to go directly to the cathode. The battery has two terminals, positive and negative. The chemical reaction in the electrolyte generates electrical energy. Electrons flow from negative terminal to positive terminal, which is creating an electric current. Next is the basic construction of battery, along with its respective parts. The metal cap, the positive part of the battery, carbon load, which is the positive electrode, zinc case, which is the negative electrode, manganese oxide, moist paste of ammonium chloride, which the electrolyte, and the metal bottom, which negative part of the battery. Now let's talk about how battery works. There are a couple of chemical reactions within the battery. At the anode, the electrode reacts with the electrolyte in a reaction that produces too many free electrons. As a result, these free electrons repel each other and try to go to a place with fewer electrons. Meanwhile, at the cathode, another chemical reaction occurs simultaneously that enables that electrode to accept electrons. In a battery, the only place to go is to the cathode, but the separator keeps the electrons from going straight from the cathode within the battery. When the circuit is closed, a wire connects the cathode and the anode. The electrons will be able to get to the cathode. The movement of electrons through the external circuits creates an electric current, and the chemical reaction within the battery continue until one or both of the electrodes are depleted of reactants. In rechargeable batteries, the reaction can be reserved during charging. Types of batteries use various materials for electrodes and electrolytes, resulting in a wide range of battery chemistries, including alkaline, lead acid, lithium ion, nickel, cadmium, and more. Each type has its own characteristics, advantages, and limitations. And let's proceed to the chemical reaction in zinc-carbon battery. Anode. Zinc undergoes oxidation and release electrons. These electrons flow through the external circuit, creating an electric current. Cathode. Manganese dioxide. Carbon is added to increase conductivity. At the manganese dioxide electrode or cathode, manganese dioxide is reduced by accepting electrons. Ammonium ions or NH4+ from the electrolyte are also involved in the reduction. Process. Electrolyte, ammonium chloride, overall reaction in the cell. Zinc or Zn plus 2MnO sub 2, 2 zinc oxide plus Mn sub 2 O sub 3. The overall cell reaction combines the anode and cathode reactions, representing the chemical changes that occurs in the zinc-carbon battery. In this type of battery, the ammonium chloride and zinc chloride electrolyte paste serves both as a source of ions for the chemical reaction and as a medium for ion transport between the anode and cathode. The cell operates until one of the reactants is depleted, at which point the battery is considered dead and cannot be recharged. The exact mechanism for this is complicated, and there is still controversy over the exact mechanism. However, the approximate half-cell reaction are anode, cathode. Another chemical reaction is the ammonium ion produces two gaseous products, which is 2NH4 plus 2E negative to 2NH3 plus H2. These products must be absorbed in order to prevent build-up or pressure in the vessel. This occurs by two mechanisms.
So, punta naman po tayo sa hydrogen fuel cell at tingnan ang working principle nito. So, as you can see po, in this left side, which is the anode side, nagsusupply ito ng hydrogen. And in the right side naman po, which is the cathode side, nagsusupply ito ng oxygen. At ang nangyayari dyan ay, because of this platinum catalyst, which reacts with oxygen, it causes it to split into two smaller particles, namely the electron and proton. At ang nangyayari pa dyan ay because of this proton exchange membrane na gawa sa polymer electrolyte membrane, it only allows proton to pass through it. At ang nangyayari sa electron ay napupersa ito na mag-travel into different route, into an external route that causes electric current. And ang nangyari sa electron and proton ay napupunta din naman niya sa cathode. which combines with oxygen, and proton plus oxygen plus electron causes water vapor. At yun lang ang ways nila. And as you can see in this figure, masasabi natin na nagpo-function din ito na parang baterya, no? And ang advantage nito ay nag-start up ito with lower temperature, kaya mas mabilis ang startup na to. At meron itong higher power density, at alam naman natin with higher power density ay meron smaller fuel cell size. Pero meron din itong mga negative side. At ang critical issue nito is water management. Kailangan kasi ng proton exchange membrane na to na maging humid. Because if it's dahil humid ito, kailangan ito dahil as the conduction of anode needs to be humid. Kung ito naman ay wet or flooded, it causes these two poles to be black, causing the particle or the hydrogen or the oxygen na hindi makapunta sa catalyst, hindi makapag-react with the catalyst kasi nga flooded itong two poles na to. Kapag dry naman, there is not enough ion acid for the proton to travel. And also, ang platinum catalyst ay easily poisoned by carbon monoxide, which causes the electrode reactions cannot take place on poison side. Hindi sila makakapag-travel into ang mga particle with the poison side.
Hello guys, today let's talk about hydrogen power plant, hydrogen fuel cell working principle. Fuel cells work like batteries, but they do not run down or need recharging. They produce electricity and heat as long as fuel is supplied. A fuel cell consists of two electrodes, a negative electrode or anode and a positive electrode or cathode, sandwiched around an electrolyte. A fuel, such as hydrogen, is fed to the anode and air is fed to the cathode. In a hydrogen fuel cell, a catalyst at the anode separates hydrogen molecules into protons and electrons, which take different paths to the cathode. The electrons go through an external circuit, creating a flow of electricity. The protons migrate through the electrolyte to the cathode, where they unite with oxygen and the electrons to produce water and heat. Hydrogen atoms enter at the anode while oxygen is fed to the cathode. The hydrogen atoms are separated into protons and electrons at the anode with the use of platinum catalyst. The now positive charged protons passes through polymer electrolyte membrane heading to the cathode. The polymer electrolyte membrane, or the PEM, is a specially treated material that looks like something like ordinary kitchen plastic wrap. It only allows positively charged ions to pass into while it blocks the electrons. The freed electrons travel through a wire creating the electric current. After passing through the circuit and the membrane accordingly, once again with the aid of platinum as catalyst, the electrons and protons meet at the cathode where they combine with oxygen to produce heat and water as byproducts. Ito yung itsura ng fuel cell. Sa next slide, i-discuss natin siya, yung video. Bali, ito yung anode, cathode. Tapos itong dalawa na to, ito yung catalyst made by of platinum. Ayan, bali, ito yung anode at cathode. Bali dito, sa hydrogen inlet, dito siya pumupunta. Papunta dito sa anode na to. Bali, nag-i-split siya into two, which are the electrons and protons. Tapos ayan, dito nagpo-flow, halimbawa meron tayo ditong valve, para gumana siya, dito nagpo-flow yung electrons, ayan, papunta dito. Tapos yung protons naman, lumalagpas lang siya dito. Dito naman, sa part na to, dito pumapasok yung oxygen. Para mag-combine dito sa cathode, mag-combine yung hydrogen, oxygen, tsaka yung electrons. Para mag-produce sila ng heat, or tinatawag natin na water, heat and water, para makapag-produce sila. Tapos dito lumalabas yung mga anyos, hydrogen. Ayan. Ganyan siya nag-work. Dito naman here are some information about how cell reactions work. Ayan siya.
As of the last update in January 2022, several factors have contributed to hydrogen power plants not yet reaching mainstream adoption. It's essential to note that the landscape may have evolved since then, but as of the last update, the following reasons were relevant. Hydrogen storage. Hydrogen is a low energy density by volume, which means large amounts of volumes of it are needed to store a significant amount of energy. This requires advanced storage technologies to make it practical for various applications. Finding suitable materials for safe and efficient hydrogen storage is a challenge. Hydrogen can use embrittlement in metals, and developing materials that can withstand hydrogen's effects over time is essential. Hydrogen leak. Hydrogen is highly flammable, and any leaks pose safety concerns. Developing and implementing safety measures as well as public perception play a crucial role in the adoption of hydrogen technologies. Hydrogen production through methane. Steam methane reforming, or SMR. The most common method of hydrogen production is SMR, which utilizes methane. However, this process releases carbon dioxide, contributing to greenhouse gas emissions. This undermines the environmental benefits of hydrogen as a clean energy carrier. Hydrogen production through water. Electrolysis. The process of splitting water into hydrogen and oxygen is energy extensive. If the electricity used for electrolysis comes from non-renewable sources, the environmental benefits of hydrogen diminish. Infrastructure development. The existing infrastructure is mainly designed for conventional energy sources. Establishing a comprehensive hydrogen infrastructure, including production, storage, transportation, and distribution, requires a significant investment. Cost. Hydrogen production, particularly using methods like electrolysis, can be expensive. The cost of producing, storing, and transporting hydrogen is a significant barrier to its widespread adoption, especially when compared to more established and cost-effective alternatives like natural gas or renewable energy. Exploring hydrogen power plants is driven by several potential advantages and considerations, as hydrogen is seen as a promising energy carrier. Here are some reasons why the exploration of hydrogen power plant is gaining attention. Clean energy source. Hydrogen is considered a clean energy carrier because when it's used in fuel cells or combustions, the only byproduct is water vapor. This makes it a potentially environmentally friendly alternative to fossil fuels, helping to reduce greenhouse gas emissions and combat climate change. Versatility. Hydrogen can be used in a variety of applications, including transportation, industrial process, and power generation. Its versatility makes it a potentially valuable component in a diversified and sustainable energy landscape. Job creation and economic growth. The development of hydrogen technologies and infrastructure can contribute to job generation and economic growth. As hydrogen industry expands, there is a potential for new employment opportunities in manufacturing, research, development, and maintenance. International collaborations. The exploration of hydrogen as an energy carrier has gained attention on a global scale. Many countries and organizations are investing in hydrogen technologies, leading to international collaboration and knowledge sharing. Despite these advantages, it's important to note that the challenges such as cost, efficiency, and the current reliance on fossil fuel for hydrogen production need to be addressed for hydrogen power plants to become mainstream and sustainable energy solution. Ongoing research and development efforts are focused on overcoming these challenges and making hydrogen a more viable component for the future energy landscape.
Hydrogen power plant. Power up with hydrogen. Latest development of hydrogen power plant. Una na nga rito ang Long Range Energy Generation Project. Ito ang pinagmamalaki na lang kauna-unahang power plant sa US or United States. The Long Range Energy Generation Project, a 485 megawatt facility being equipped to run on a mix of natural gas and carbon-free hydrogen, is nearing completion on the site of a former aluminum smelter on the banks of the Ohio River. The facility first will burn a fuel blend that includes 5% hydrogen in a General Electric Corporation H-class gas turbine. The plan is intended to transition to 100% green hydrogen over the next decade by relying increasingly on renewable energy to power electrolysis machines that split water into its hydrogen and oxygen element, according to Hearing 2021. This is the image of Long Range Energy Generation Project being constructed in Ohio, USA. Next, Siemens Energy. Construction begins on the world's largest green hydrogen power plant, part of unique base load solar project. Siemens Energy will operate the unique 170 million euro facility in a remote part of French Guiana, which will provide 10 megawatt of power during the day and 3 megawatt at night. A unique base load renewables project that combines the world's largest hydrogen power plant with a 16 megawatt machine for electrolysis of water, at 3 megawatt fuel cells, 55 megawatt of solar panels, and 20 megawatt per 38 megawatt hour of batteries has begun construction in French Guiana Collins 2021. This is the image of hydrogen for the chemical industry at Siemens Energy. The world's largest green hydrogen projects. This is the latest world's largest green hydrogen projects according to LinkedIn Future Fuels. Una na nga dito ang NEOM Green Hydrogen Project na matatagpuan sa Saudi Arabia. When commissioned in 2026, it will produce 600 tons per day of clean hydrogen by electrolysis using ThyssenKrupp technology, production of nitrogen by air separation using Air Products technology. NEOM Green Hydrogen Company's mega plant will integrate up to 4 gigawatt of solar and wind energy to produce up to 1.2 million tons of green ammonia, translating up to 600 tons per day of carbon-free hydrogen. Once the plant at NEOM is operated by 2026, 100% of the green hydrogen produced will be available for global export in the form of ammonia through an exclusive long-term agreement with Air Products. Next is Sinopec's Ordos Green Hydrogen Project na matatagpuan sa China. The installed design capacity for wind and solar power generation will be 450 megawatts and 270 megawatts respectively. The production capacity of hydrogen through electrolyzed water is 30,000 metric tons per year, and the hydrogen storage capacity is 288,000 standard cubic meters. The total investment of the project is about 5.7 billion yuan, or converted to US dollar, 848.21 million US dollar. Next, TES Green Hydrogen Project na matatagpuan sa Germany. Fortescue Future Industry, FFI, and Tree Energy Solutions, or TES, both companies stacked with a very smart and far-seeing team, have agreed to develop the world's largest green hydrogen integrated project to help Europe mitigate its current energy and climate crisis and to bring green molecules to Europe. The first phase of this partnership is to jointly develop and invest in a supply of 300,000 tons of green hydrogen with final location being currently agreed. Final investment decision target for 2023. Next is Plug Power Green Hydrogen plants na matatagpuan naman sa Finland. Plug Power Incorporation plans to develop 3 green hydrogen production plants in Finland, resulting in the production of 850 tons per day of green hydrogen or 2.2 gigawatts of electrolyzer capacity by the end of the decade with final investment decision FID by 2025 or 2026. Next is Western Green Energy Hub or WGEH Australia. The Western Green Energy Hub would stretch across 15,000 square kilometers and could produce up to 50 gigawatts of energy. The hub would produce 3.5 million tons of zero carbon green hydrogen or 20 million tons of green ammonia each year for both domestic consumption and export. Now, nakita na natin yung latest development of hydrogen power plants sa buong mundo ngayon. Let's see kung ano naman ang latest development of hydrogen power plant in Southeast Asia. Tayo matatagpuan sa Philippines. Philippines' first hydrogen power plant project. This is the image of na pagtatayuan ng first hydrogen power plant project na matatagpuan sa Zamboanga City or Zamboanga, Sibugay. The provincial government of Zamboanga, Sibugay under the leadership of Governor Dulce Ann Hofer is set to buy a lot in the municipality of Talusan, Zamboanga, Sibugay on Oluntanga Island, where the first hydrogen power plant project in the Philippines and Southeast Asia will be built. The All-Tamo Development Alliance, representing 3 municipalities of the province, namely Olutanga, Talusan, and Mabuhay, will directly benefit from the project, which will help reduce energy costs, sustain grid stability, increase penetration of renewables, and build energy independence. Hydrogen de France, or HDF, an independent power producer in partnership with the Mindanao Development Authority, or MINDA, through the HDF Renew Stable Energy Project will construct the hydrogen power plant in Mindanao. HDF needs a minimum of 3 years to put up the 10 megawatt project for them to mobilize, conduct pre-development to develop stage, and conduct a series of studies such as feasibility, environmental, hydro, and geotechnical. Similar project will be implemented in 10 more areas in Mindanao, including Zamboanga del Norte and in the island of Basilan, Sulu, and Tawi-Tawi, which have a shortage of electricity supply. Before we end this presentation, ito lang yung slogan mula kay Dan Lipinski. The environmental benefits of hydrogen are also outstanding. When used as an energy source, hydrogen produces no emissions besides water, zero polluting emissions, and amazing advance over the current source of energy that we use. Thank you for listening. Have a great day, everyone.